The National Electrical Code, or NEC, does not provide specific requirements for the frequency of checking and maintaining the electrolyte in storage batteries. The NEC focuses on safety and proper installation, rather than dictating maintenance schedules for specific components. Electrolyte maintenance is crucial for the optimal performance and lifespan of storage batteries. The specific gravity and level of the electrolyte directly impact a battery's ability to store and deliver power. Factors influencing the electrolyte's condition include the battery's age, usage patterns, operating temperature, and charging regime. The frequency of inspection and maintenance should be determined by several factors. Firstly, manufacturer recommendations are paramount. Battery manufacturers provide detailed guidelines regarding the recommended intervals for checking electrolyte levels, specific gravity, and performing necessary maintenance procedures. Adhering to these recommendations is crucial for maintaining warranty validity and ensuring optimal battery performance. Secondly, the operating environment plays a significant role. Batteries operating in high-temperature environments tend to experience accelerated electrolyte evaporation and degradation. In such cases, more frequent inspections are necessary to prevent electrolyte levels from dropping below critical thresholds. Similarly, batteries subjected to frequent cycling or deep discharges may require more frequent maintenance. Thirdly, the criticality of the application influences maintenance schedules. In critical applications such as emergency power systems, uninterruptible power supplies, or telecommunications equipment, even minor battery performance degradation can have severe consequences. Therefore, more frequent and rigorous maintenance procedures are warranted to ensure reliable operation. Fourthly, a comprehensive maintenance program should include visual inspections. Regularly visually inspecting batteries for signs of corrosion, bulging, or leakage is essential. Corrosion around terminals can impede electrical connections and reduce battery performance. Bulging or leakage may indicate internal damage or electrolyte imbalance. Any signs of physical damage should be addressed promptly to prevent further degradation. Fifthly, measuring electrolyte-specific gravity is essential. Specific gravity is a measure of the electrolyte's density and provides an indication of the battery's state of charge. A hydrometer is typically used to measure specific gravity. Comparing specific gravity readings to manufacturer specifications can help identify batteries that are undercharged, overcharged, or experiencing electrolyte degradation. Sixthly, electrolyte level checks are critical. The electrolyte level should be maintained at the recommended level as specified by the manufacturer. Low electrolyte levels can expose battery plates to air, leading to sulfation and reduced capacity. Distilled water should be added to maintain the correct electrolyte level. It is important to use distilled water to avoid introducing impurities that can contaminate the electrolyte and shorten battery life. Seventhly, equalization charging should be performed periodically. Equalization charging is a controlled overcharge that helps to correct electrolyte imbalances and remove sulfation from battery plates. This process ensures that all cells within the battery bank are fully charged and performing optimally. The frequency of equalization charging depends on the battery type, usage patterns, and manufacturer recommendations. Eighthly, terminal cleaning and tightening are important. Battery terminals should be cleaned regularly to remove corrosion and ensure good electrical connections. A wire brush and a baking soda solution can be used to clean corroded terminals. After cleaning, terminals should be tightened to the manufacturer's specified torque to prevent loose connections and arcing. Ninthly, proper ventilation is necessary. Batteries release hydrogen gas during charging, which is flammable and potentially explosive. Adequate ventilation should be provided to prevent the accumulation of hydrogen gas. Battery rooms should be well ventilated or equipped with hydrogen gas detectors. Tenthly, record keeping is essential. Maintaining accurate records of all inspections, maintenance procedures, and test results is crucial for tracking battery performance and identifying potential problems. These records can be used to establish trends, predict battery life, and optimize maintenance schedules. In summary, while the NEC does not mandate specific maintenance intervals for storage battery electrolyte, regular inspection and maintenance are vital for ensuring optimal battery performance, reliability, and longevity. Following manufacturer recommendations considering the operating environment and application criticality, and implementing a comprehensive maintenance program are essential for maximizing battery lifespan and preventing costly failures.